Imagine turning a 5-step trigonometry problem into a 1-step trigonometric problem. So yes, today we are going to see transformations of the formulas which we saw earlier, and it's just a list of formulas, and I would like to revisit that. Sine of a plus b plus sine of a minus b would give me 2 sine a cos b. So I would like to take the basic identities, and I would like to just add up those, add or subtract based on that. So sine of a plus b minus sine of a minus b would give me 2 cos a sine b. Same way cos of a plus b plus cos of a minus b. Same way here with the minus a plus b cos of a minus b. This would end up getting 2 cos a cos b, and here minus 2 sin a sin b. Okay, so this is what the basic 4 identities where we were adding and subtracting those ratios. So now let's substitute, and I would like to substitute a plus b as c and a minus b as d. Then if I add both of these equation, which means this is 1 and this is 2. So if I add 1 plus 2, I would get 2a is equal to c plus d, which means a equal to c plus d by 2. And if I 1 minus 2, I would get 2b, which is nothing but c minus d, which implies b is equal to c minus d by 2. Okay. So I'm just substituting this basic 4 identities in terms of c and d. It was earlier based on a and b. Now it's completely transformed into c and d. Now what we would get is sine c plus sine d can also be written as 2 sine c plus d by 2 cos c minus d by 2. This is 1. Okay, I would put 5 better. 6 now. Sine c minus sine d is equal to 2 cos of c plus d by 2 and cos sine would be sine of c minus d by 2. It's just very simple. I'm just substituting a plus b is equal to c and a minus b is equal to d. That's it. Cos c plus cos d cos c minus cos d is equal to minus 2, and here 2 2 cos of c plus d by 2 cos of c minus d by 2, and here the same thing with the sine c plus d by 2 sine of c minus d by 2, and hence this is called transformation, and it's mainly used in order to reduce the steps from reduce the growing steps and getting bulky answers. So we can reduce that bulky answers into short and sweet, and we would get the answers in a like short and sweet manner. So let's solve some sums so that we could get some idea. If x is equal to Sine alpha plus sine beta. Y is equal to cos alpha plus cos beta. Then find tan alpha plus tan beta. Tan alpha plus tan beta in terms of x and y. So yes, now we have to find tan alpha plus tan beta in terms of x and y, and x is given as sin alpha plus sin beta, and y is given as cos alpha plus cos beta. Now, in order to get tan, we should divide the numerator and denominator. So sine, numerator involves sine and cos, denominator involves cos. So let's divide x by y would give me sin alpha plus sin beta divided by cos alpha plus cos beta. Now using the expressions sin c plus sin d equal to 2 sin c plus d by 2 cos c minus d by 2 and cos alpha plus cos beta equal to this thing. So I would get, okay, let's substitute better for better understanding. 2 and 2 numerator. Yes, alpha plus beta by 2 and cos alpha minus beta by 2. Okay. And here I would get cos of alpha plus beta by 2 and cos of alpha minus beta by 2. So this both get cancelled and 2 get cancelled. So I would end up getting tan of alpha plus beta by 2, which is x by y. And they wanted tan alpha plus tan beta. So this is tan of alpha plus beta by divided by 2, which is x by y. Now we should solve again. We all know that sine of alpha plus beta, I mean sine of a plus b is equal to, now we can expand this as 2 times of alpha plus beta by 2 divided by, in the sense I am just using sine 2 theta formula here, equal to 2 tan theta divided by 1 plus tan square theta. So I'm just using that tan square alpha plus beta by 2. Here alpha plus beta by 2 and here 2 times, so alpha plus beta, and here it is reduced to half, so alpha plus beta by 2. So hope you could understand this. Here, now I'm just substituting x by y. We got this right. So I'm just substituting that. So I'm just doing this because I want tan of alpha plus beta in terms of C, tan of alpha plus tan beta in terms of x and y. So I'm just adjusting based on that. 2 x by y, right? Yeah, 2 x by y divided by 1 plus x square by y square. So after like getting the denominator 2x by y to y square by x square plus y square. So I can just cancel and I will get 2xy by x square plus y square sine of alpha plus beta. And from this we can deduce the cos of alpha plus beta. Uh, 1 minus tan square alpha plus beta by 2 divided by 1 plus tan square alpha plus beta by 2. So I would get 1 minus x square by y square divided by 1 plus x square by y square, and y square just get cancelled, and we would get y square minus x square divided by y square plus x square. Okay. Cos of alpha plus beta is equal to y square minus x square divided by y square plus x square. Okay. So sine and cos I got, and they want tan alpha plus tan beta. It's not. But x square plus y square is sine alpha square. Sine alpha plus sine beta the whole square plus cos alpha plus cos beta the whole square. So this would end up with x sine square alpha plus sine square beta plus 2 sine alpha sine beta plus cos square alpha plus cos square beta plus 2 cos alpha cos beta. So we all know that sine square alpha plus cos square alpha is equal to 1, and sine square beta and cos square beta is equal to 1. 1 plus 1 plus 2 s alpha s beta plus 2 c alpha c beta. So I would get 2 plus 2 sin alpha sin beta plus 2 cos alpha cos beta. Sin alpha sin beta plus cos alpha cos beta. Sin alpha sin beta. This I can like write it as cos A cos B plus sin A sin B, that format. So I would get 2 plus 2 common, and I would get cos of alpha minus beta. So cos of A minus B is equal to cos A cos B plus sin A sin B. So I am just substituting that. So this is what uh, x square plus y square would bring me. Now cos of alpha plus beta can be, now cos of alpha plus beta can be written as, I'm just substituting the same. Okay. I'm just substituting this on cos of alpha plus beta. I get cos of alpha minus, cos of alpha minus beta. Okay, this is 1. Let's keep it, okay, this 9. Let's name it as 9, this as 10. And now let's solve this and get 11. From this, cos of alpha minus beta is equal to, we can deduce that x square plus y square minus 2 divided by 2. From this, here inferring. Now tan alpha plus tan beta is equal to sine of alpha plus beta divided by cos alpha cos beta. This is very, very important identity deduced. Why? Because you can derive this using the tan of alpha plus beta, which means tan alpha plus tan beta divided by 1 minus tan alpha tan beta. From that, you could deduce this equation, and you would be getting in terms of sine and cos like this, which means sine of alpha plus beta can be written as 2 sine alpha plus beta divided by cos of alpha plus beta minus the sense, wait, we can write like this. Okay, see, sine of alpha plus beta can be written as sine of alpha plus beta divided by cos alpha cos beta can be written in transformation form as like this one. I'm just using this one, and here 2 is extra fitting and we just don't require here, so I'm just dividing it by 2. So this 2 when goes to the numerator, I would get 2 sine alpha plus beta divided by cos of alpha plus beta plus cos of alpha minus beta. If we substitute in terms of x and y's, we would get finally, after solving all those things, we would get 2 into 4xy divided by y square, the sense 2 of y square minus x square plus so alpha alpha plus beta while substituting, I will get this, and then after solving x square plus y square into x square plus y square minus what you'd end up getting like this tan alpha plus tan beta. So the numerator can also be written as 8xy divided by 2 of y square minus x square plus x square plus y square plus x square plus y square minus 1. That's the thing. So we got tan alpha plus tan beta in terms of x and y. Yes, we got this. So now let's solve like second example. If given a plus b plus c is equal to 180 degree, and it won't be that complex, this one. This would be really easy. Then sine square a by 2 plus sine square b by 2 plus sine square c by 2 is equal to sigma. Find. They are asking us to find. So s square a by 2 plus s square b by 2 plus s square c by 2. Now let's resolve this. Now we can expand this in terms of cos 1 minus cos a by 2 plus 1 minus cos b by 2 plus 1 minus cos c by 2. Now this half, we are grouping all those half plus half plus half minus of cos A plus cos B plus cos C divided by 2. So we would get 3 by 2 minus CA plus CB plus CC by 2. This is what we would get. And then cos A, cos B, cos C. 3 by 2 minus 1 by 2 of cos A, cos B, cos C. But they want, I guess they want in terms of sine terms. So we got this in sine cos terms, and we have to re-evaluate again and get in terms of sine terms. You would be asking, LHS is already there with sine terms. No, they are just asking us to uh, rewrite the expression in terms of again sine terms. So let's solve it again. 3 by 2 minus 1 by 2 of now cos A plus cos B plus cos C can be written as 1 plus 4 times of sine A by 2 sine B by 2 sine C by 2. I would tell you why 4 is coming. It's just because they are just combining two different equations. Cos A plus cos B, when evaluated, you would get something like 2 sine a plus b by 2 and sine a minus b by 2, something like that. And then, 2 cos c plus d by 2 and 2 cos a plus b by 2 and cos a minus b by 2. You will be getting like that. And with this taking as an expression and comparing with the cos c, you would be getting another 2 multiplied again. So you would get 2 into 2, and then you lastly add that ratios in terms of cos, right? Cos of a plus b by 2 and cos of a minus b by 2. Then along with cos c, when you interpret, you turning all those ratios into sine. So that's the fact. Cos a plus cos b plus cos c would end up giving you 1 plus 4 sin a by 2, sin b by 2, sin c by 2. There is a statistic, there is a proof regarding it, and I will show you in one more video. Now, let's just evaluate it. 3 by 2 minus 1 by 2 minus 2 sin a by 2 sin b by 2 sin c by 2, which means 1 minus 2 sca by 2 sb by 2 sc by 2, which is nothing but sine square a by 2 plus sine square b by 2 plus sine square c by 2. Minus 2 sine a by 2 sine b by 2 sine c by 2. This is the final answer. So, transformations actually help us in dealing the things very easily and so fast. The thing is, you have to adjust the LHS and RHS accordingly as per the proof or as per what they are asking in terms of what ratio they would want you to ask. So you should use the right trigonometric identities in order to make those steps clear, and you would get stuck up at some random area and you'd be thinking what to use, where to use. So just tabulate all those identities and derive everything one from the another, and just think which would suit in order to get the LHS accordingly. Yes, please like, share, and subscribe. Thank you.